Good morning, class. Welcome to geometry class via the video camera. Go ahead and open up in your books to lesson 101 on page 656. Hopefully you did well on your homework that you've checked. And as we're turning there to lesson 101, let's review the three types of lines we have talked about regarding circles. One is a tangent that touches a circle at one point. One is a secant that goes through the circle, intersecting at 2 points and goes beyond the circle. Another one that we've learned is also our chord. A chord has its endpoints. It's a line segment that has its endpoints on the circle. Again, different from the secant. The secant continues on beyond the circle and the chord stops here. We're going to be focusing on the tangent and a secant today and how to determine their measures. Let's look first at two secants. When I have two secants, these are always going to be, we're talking about secants and tangents that intersect outside of the circle. They intersect at a common point here. Not just two random secants within a circle, but two secants that intersect at an external point outside of the circle. They're going to be the products of each other. Look closely at how we find these products. It is going to be AB, which is this external segment here, times AC. Notice that is from the external point all the way to the second intersecting point here. The first one is this first piece, AB, AC, not BC, all the way through. AC equals the same thing on this lower secant. AD, the external piece, times AE, all the way through from the external point all the way through to the second end point. That is how we can find the measures for secants. That's how we can find the measures for secants. This external segment times the whole length of the segment. This external segment times the whole length of the secant. Not just DE. This is not included here. So if I was given this piece of 3 and this piece of 7, it would be 3 times, not 7, but 10. I'm taking the whole segment there, 3 plus the 7, giving us that product. The external segment and the internal segment, the whole segment. Let's look at two tangents, a secant and a tangent. A secant and a tangent are also going to be very, very similar. It is from the external point to the tangent point. Now look this time, we only have one point there. So it is AB times AB, which is AB squared. Again, we have a tangent and a secant intersecting at a common point outside of the circle. Since we don't have two endpoints, we're going from this point to here. It's going to be AB squared equals, just like we did before, AC, the external segment, times AD, the whole segment from the external point to the second point of intersection, AD. Again, AB squared for the tangent section squared is to the external segment times the whole segment. Once again, like we mentioned before, if this were 3 and this were 7, we are multiplying 3 times not 7, but 10. This whole length here from the intersecting point, the farthest one, to the external point. Let's look at example 1 on page 656. This will show you the area where you really need to be careful when you're doing these. This is the unknown piece that we're solving for, PS here, this external segment. Keep in mind, this ST is 9. This ST is 9, but we don't want ST. We want from ST all the way to P, from T to P here. So let's look at what that's going to look like. It is 3, the external segment, times not 27, but the whole section here from P to R, which is 27 plus 3, which is 30, equals, X is my external segment. Now my whole segment from P to T is not 9, but X plus 9. Let's solve this algebraically. 3 times 30 is going to give me 90. X, I'm going to have to distribute this to each term inside. X times X is X squared. X times 9 is 9X. I now need to get everything on one side. Need to subtract 90 from both sides. I now am going to have to factor. That's right. I know, everybody's favorite. I'm going to have to factor. Let's go ahead. My factors, we can cheat and use our book to help us here. X minus 6 and X plus 15. Giving us a value of X equals 6 or X equals negative 15. We can't have a negative length for this. We can't have a negative 15. So that is ruled out. My section is 6 here. X equals 6. X equals 6. The part to keep and be careful of is that you do 3 times 30, not 3 times 27. That you do X times X plus 9, not X times 9. That's the only thing you really have to watch out on these. Let's look at another example. Look at example 3 in your book. Look at example 3. On this one, we have a tangent and a secant. Remember, when we have a tangent and a secant, we're dealing with a squared term for our tangent, a squared term for our tangent. Secant is still done the exact same way. The external segment, which on this one is 9 inches, and our internal is 16 inches. And this is what we're trying to find here. Our TW, which is a value of X here. This time it is going to be squared. It is going to be squared. So I'm going to have X squared. My tangent is a squared term here. X squared equals my external segment, which is 9, times not 16. That's the biggest danger that people have with these, or the biggest mistake, common mistake. It is 9 times 9 plus 16, which is 25. That's going to give me X squared equals 9 times 25 is 225. We know this already. We should know the square root of 225. Therefore, X equals 15. X equals 15. Our length value here, it is inches. Our length of our tangent is 15. Again, the biggest thing to be careful of on these is that you're using the whole section, not just this measure here. There's nothing that measures from here to here as our product. The example you see on example 4 is doing the same thing, except they're giving you the earth and a balloon, and you can follow through that example. All right, I'm going to go ahead and sign your homework. Miss LaFay will put it on the board for you. Good luck, and we'll see you on the videos tomorrow.